Hello, folks. We continue our lectures with the intersection of three planes. I have a sort of like flow chart that I'm going to show it to you here, and maybe you can see it better right now. It shows the intersection of three planes, and it is a flow chart that gives you the procedure to narrow down your search in finding uh, what is the situation among three planes. So given a system of equations, which represents given three equations of a plane, uh, we first find the normal vectors, obviously, and then we do a collinearity check, as you see in the flowchart. If the answer is yes to the collinearity check, if you can find any pair of collinear normal vectors, then your answer is yes. So you go to one branch of the flowchart and you're going to see if you have two or three collinear vectors. If you have three collinear vectors, then it means that the three planes are actually parallel, but they could be parallel and coincident, or they could be parallel and distinct. And there's three scenarios in the flowchart, as you see. And it's like this case here. Maybe you can see it better now. And by finding the ratios of A1 over A2, B1 over B2, C1 over C2, D1 over D2, you can distinguish which scenario that is. Is it that the three planes are parallel and distinct, or they're actually parallel and coincident? Or maybe two of them are coincident and the third one is distinct and parallel. So this is the scenario when we have three collinear vectors. If you have two collinear vectors, that means that two of the planes are parallel and distinct or coincident, and the third plane, as you see in this flowchart, is intersecting the other two parallel planes. And again, in order to distinguish between these two, you can check those ratios of A1 over A2, B1 over B2, and so on and so forth. So this is the scenario if any of two planes are parallel. But if your answer to the collinearity check is not a yes, then you go the other way of the branch. And here you see that we are dealing with a coplanarity scenario. So we have to do a coplanarity check using triple scalar product. Then in that case, either your answer is yes to the triple scalar product being zero, or you're going to say no, the triple scalar product is not zero. If it is not zero, it means that the three vectors are not coplanar, Therefore, it would be the corner of a room scenario, and the three planes will be intersecting at one point of intersection. But if you would say the triple scalar product is actually zero, this means that you admit that the three normal vectors of the plane are coplanar. And if they are coplanar, we have two scenarios, that may be happening. Either it's a triangular prism scenario, or it is the textbook scenario, right? So in order to distinguish between these two, of course, we have to check the existence of solution. If the system of equations has a solution, then that will be the textbook scenario where all the three planes are intersecting at one line of intersection. Otherwise, it will be the triangular prism scenario. So this flowchart summarizes basically the whole procedure of finding which one of the 8 cases do we have given three equations of planes. Okay, so you may pause for a second and maybe take notes, or at your discretion check this flowchart out. And now this is just one example. We have 3 planes, and we just have to follow and see which one of the 8 cases are we dealing with here. So the first thing I just showed you in the flowchart was to find the normal vectors. So without hesitation, N1 would be 2, 5, 1, N2 would be 3, -2, and 5, and vector N3, the normal vector of the third plane, would be 1, 31, and -10. You clearly see that by simple investigation, none of these vectors are collinear. None of these vectors are parallel to one another. So I would write here, none are collinear, because not any vector is a multiple of the other vector. So the next thing we have to do, after eliminating 5 cases among 8 cases, in the journey of narrowing down our search, so it's either this scenario or that scenario or that scenario, basically, okay? So we have to do a coplanarity check right now, okay? And to do the coplanarity check, we're going to be using triple scalar product. So we're going to go N1 dot N2 cross N3. This is the triple scalar product. So vector N1 is 2, 5, 1, and cross product of vectors N2 and N3 is actually -135 and 35 and 95. You can do the calculation and check to see if it's right or not. Now, if you do the dot product, you get -270, 2 times -135, and then plus 175, that's 5 times 35, and plus 95. And guess what? This sum is equal to 0. That means that the triple scalar product of the 3 normal vectors of the planes is 0. What's the message? The message is that the vectors are actually coplanar. So the 3 normal vectors are coplanar. So if they're coplanar, they cannot meet at one single point of intersection. So it could be either the triangular prism scenario, this one, or it could be the textbook scenario, where the pages of the textbook meet at one line of intersection. So out of 8 possibilities, 6 of them we put aside, and now we narrowed down our search, and we got either this scenario or that scenario, okay? So to figure out which one it is, we have to actually solve the system of equations, and we have to see if we have solution or we don't have solution, okay? If we have solution for the system of equations, it will be this case. If we don't have a solution, if the system of equations does not have any solution, then it will be the triangular prism scenario, basically. So now I have to use elimination method to solve the system of equations. So again, I'm numbering the equations, number 1, number 2, number 3, so that I can refer to them easily. Perhaps I can multiply the third equation by 3, so 2 times equation number 3, and I add it with equation number 1, okay? So 2 times x plus 2x, and not adding them, but subtracting, because I want to eliminate, right? So I'm going to multiply twice. I'm going to multiply the third equation by 2, and then I'm going to subtract from equation number 1. So this way, 2x minus 2x cancel each other. So let's do it. So 2x minus 2x is just 0. Doing mental math here. And then actually, let's do it. That's fine. 2x plus 62 y minus 20z plus 14 equals 0. This is double the third equation. And the first equation, I already had it from before. So now I subtract them. I wanted to do all this mentally, but you know what? Why not showing work? So 2x minus 2x cancel out each other. 62y minus 5y would be 57y, right? Negative 20z minus 1z, it would be negative 21z. And 14 minus 3 is 14 plus 3, which is 17 equals 0. Okay, so we get 57y equals 21z minus 17. Okay, this is one equation we got, and we have to see if we can simplify the equation. If yes, we will, but it doesn't seem so. So we're going to say y equals 21z over 57 minus 17 over 57, dividing both sides by 57. Okay, now in the system we had equation 2 and 3. If I multiply the third equation by -3, add it with 3, again I can eliminate x. So I'm multiplying the third equation by -3 and add it with the equation number 2. So -3x plus 3 is just 0. Or it's okay, let me again show the work. But you don't know how hard it is to do these questions in limited period of time. So -3x minus 93, that's multiplying by 3, right? 93y and -30z plus multiplied by -3, multiplied by -3, multiplied by -3, that would be positive 30z, multiplied by -3, that would be -21 equals 0. Okay, we multiplied the third equation by -3 right here, and we took the second equation, and now we're going to add them up to cancel out 3x and -3x. So when you add them up, -95y plus 35z minus 20 equals 0. And all of these are divisible by 5. So if you divide it by 5, you get -19y plus 7z minus 4 equals 0. I divided both sides of the equation by 5. 20 divided by 5 is 4. 35 divided by 5 is 7. And 95 divided by 5 is 19. Okay? So from here, y would be -7z plus 4 all over -19. So that is 7 over 19z and minus 4 over 19. So I found y here, and I had found y before. Okay, so we know that y should equal to y. So that means 21z over 57 minus 17 over 57 should equal to 7 over 19z minus 4 over 19. And this way, we can solve for z, hopefully. Okay, so rearranging the terms, 21 over 57 minus 7 over 19. Z, isolate the variable on the left-hand side. 17 over 57 minus 4 over 19 on the right side. So we need to use a calculator. So 21 over 57 minus 7 over 19, that is 0. Interesting, because 3 times 7 is 21, and 3 times 19 is 57, so it is equal to 0. So 0z equals, now the right side is 17 over 57 minus 4 over 19. Okay, that's 5 over 57, some sort of fraction, non-zero fraction. Okay, so 0z equals 5 over 57. Now, do you think this equation has any solution? Do you think you can find a z value that when you multiply it by 0, you end up with a non-zero fraction of 5 over 57? Obviously, the answer is no. So this equation has no real solution. Is that correct? So when you have no real solution, it means that the system of equations does not have any solution, and we don't have any line of intersection. We don't have any point of intersection So it should be this scenario of the triangular prism. So I would say the three planes intersect in the form of a triangular prism, which is that case. So you see how we started the journey by finding the normal vectors and then checking to see if they're collinear. We said no. We omitted 5 scenarios out of 8 scenarios right there. And then we found the triple scalar product. We figured out that the 3 normal vectors are coplanar. And because they were coplanar, this case where we have one unique solution, we just omitted that case from our list as well. We crossed it out. And we were left with 2 scenarios where the normal vectors were actually coplanar. And then we started solving the system of equations by the method of elimination. And we figured out that unfortunately the system of equations does not have any real solution. And that means that we are faced with the triangular prism scenario. And it's not this case, because if it was this case, we would probably have a 0 on the right hand side, 0 z equals 0, we would have infinitely many solutions. In that case, we would let z equal to t, like we have done in the past, and then we would find y in terms of t and x in terms of t, and that would be actually the parametric equation of the line of intersection. That would be the case. But in this case, we ended up with the triangular prism. I hope you understood how we are finding or actually solving system equations with 3 unknowns and basically finding intersection of 3 planes. Thank you.